Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn instantaneous velocity, instantaneous acceleration, and how the differentiation and integration is useful in all these things. Okay students, so let's start the video and let's learn all these basic things. Okay, so here you can see very well. The first topic is instantaneous speed, or even we can tell instantaneous velocity also. Both the things are same. So kindly see here. The velocity of an object at any instant of time is known as its instantaneous velocity. Again I am telling that velocity of the object at any particular instant of time. Okay. Now even we can explain in another way also. See here. It is also defined as the limit of average velocity when time interval is very small. Because normally what happens in case of average velocity, we have some time interval like t1 to t2. But in case of instantaneous velocity, we have one particular instant. That means what will happen? The time interval will be very, very small. Okay. So if I write here the mathematically, we can write here this instantaneous velocity v is given by, remember that here, limit this time interval tends to 0, and here we can write here delta x by delta t, that you know very well. This is the average velocity. So the limit of average velocity when time interval delta t is the very, very small. Okay, because delta t should not be equal to 0, otherwise it will become infinite, undefined. Okay, so what will happen that here in this situation I can write here this v equal to dx by dt. What is this? V equal to dx by dt. And when you are doing the differentiation, just write like this, d by dt always together, and like this you can write d by dt of x. Okay, even we can write like this also. You know very well what is the physical significance of the differentiation? Slope. So if in case we have the position time graph, so slope of xt graph, we will see in a detail about the graphs and all that, but as of now you should know that the slope of xt graph will give us the velocity. Okay, so this thing you should remember that very well. Okay, can you see it, how we have done it? Is it? Now students, here we have done for the point of view of the differentiation. Okay, now again if I write here, see, as we know v equal to dx by dt. Okay, if I do the cross multiplication, I can write here, see very well, dx equal to v dt, na? Just a cross multiplication. Now after that, if I put here the limit, first integration sign, na? And if I put here the limit, let's take here dt, na? So t equal to t1, and here dx means let's take x equal to x1. This is called the lower limit. After that, final time is t2 and the final position is x2. So this is called the upper limit. Okay students, so here also you can write in this form also. Okay, this is also one form is there. Okay, so what we have to remember that here, if in case x position is given and we want to calculate the velocity, what we have to do? We have to do here the differentiation, because v equal to dx by dt. Similarly, when we are going in reverse direction, what we have to do? We have to do here the integration. Okay, remember that here x is the position, v is the velocity. I hope so you have understood very well. So now students, after that we'll see some important points are there under the note. You can see very well, instantaneous velocity is a vector quantity. Yes, anyhow we know that. SI unit is meter per second. Some other units are like kilometer per hour and all that. That you know very well. Third one is the dimensional formula is we know very well, LT minus 1. And you can see instantaneous velocity can be positive, negative or 0. How it can be? Because it is the vector quantity, and vector quantity can be positive, negative or 0 also. Okay, great. So after seeing the instantaneous velocity, we are seeing the some important points now. So see here, this next point, see. For uniform velocity will always takes place in a straight line motion SLM, because uniform velocity means magnitude should not change and direction also should not change, and that is only possible in a straight line motion. Okay, so remember that it will be always helpful for you whenever uniform velocity, it will always takes place in a straight line motion. Okay, so for uniform velocity of an object, there should be equal change in displacement in equal interval of time. Okay, equal change in displacement in a equal interval of time. Okay, so here please, for example, I have taken the time t equal to 0, t equal to 3, t equal to 6, and t equal to 9, okay, seconds. Let's take here for example seconds. Now, so you can see very well what is the time interval is there, 3 seconds, 3 seconds, 3 seconds, and 3 seconds, okay. So let's take for example here the position. Let's take for example x equal to 1 meter. After that, let's take for example, let's take x equal to 2 meter, okay, x equal to 3 meter, and x equal to 4 meter. So can you see very well, students, here the time interval is the 0 to 3 seconds. That means in first 3 seconds how much traveling? 1 to 2, that means 1 meter displacement. Again 3 to 6 seconds, that means time interval 3 seconds. Again how much traveling? X equal to 2 meter to x equal to 3 meter. Again 1 meter. Last, again t equal to 6 seconds to t equal to 9 seconds, time interval 3 seconds. Again how much it is traveling? 3 meter to 4 meter. That means again displacement how much here? 1 meter. So only we can tell the students that there should be equal change in displacement in equal interval of time. Then only what is that? Uniform velocity. Okay. Similarly, if we see next point, can you see here? For non-uniform velocity of an object, there should be unequal change in displacement in equal interval of time, okay, or we can tell here in another way, equal change in displacement in unequal interval of time, okay. Both the things you should know very well. Now if I take some examples are here, let's take for example again in the same way, t equal to 0 second, t equal to 3 second, next one t equal to 6 second, you can see very well, and next one what I have taken, t equal to 9 second, okay. And now let's take what is happening that here. Let's take here for example, here x equal to 1 meter, and let's take here it happened, let's take x equal to for example 3 meter, then let's take for example happen x equal to 10 meter, and let's take it has happened x equal to 20 meter, okay. So you can see very well, first 3 seconds traveling 2 meter because 1 to 3, next 3 seconds traveling 3 to 10, that means 7, and again next 3 seconds traveling 10 to 20, that means 10, okay. So here what is happening, in an equal interval of time, unequal change in displacement is there. So you kindly see very well, this is the uniform velocity and a non-uniform velocity, okay, great, all these basics needed. Next one we can see some basic things. So see here, the question is, position of an object is x equal to 3t square plus 4t minus 1. Calculate the instantaneous velocity at t equal to 3 seconds. Okay, so we'll write here, see, as v equal to dx by dt. With very basic I will do for you. So we can write here d by dt of x. Okay, now this d by dt, put the value of x from here. What is this? 3t square plus 4t minus 1. Okay, now we will just make it into the parts. So d by dt of 3t square. Okay, very basic, d by dt of 4t and minus d by dt of 1. Okay, can you see very well? After that, what will happen at here? See here, v equal to product of constant and variable. So this constant will come outside. So 3 into d by dt of t square plus 4 is constant, d by dt of t minus d by dt of constant. D by dt of constant, always remember that here 0. Okay, so what this will become here? 3 d by dt of t square. Please remember this formula I will tell you. No? D by dt of t to the power n means nt n minus 1. Okay, this formula only you have to use it. All the things will come here. Okay, so d by dt of t square, when you will put here n equal to 2. So what this will become here? It will become here 2 t to the power 2 minus 1. Now, very basic. Plus 4 d by dt of t power 1 means what we can write here? 1 into t power 1 minus 1. So what this will become here? 3 into 2t plus 4. T power 0 means 1. See here please, t power 0. So what we can write here? See, 6t plus 4. What velocity is coming here? Kindly see very well how we have done here. V equal to 6t plus 4. And at which time they are asking? They are asking at t equal to 3 seconds. So V at t equal to 3 means like here 6 into 3 plus 4. So 6 into 3 means 6 3 is 18 plus 4, that means 22 meter per second. Now, so with too much basic way, in a very basic way, we have done this question, and the final answer is how much? The final answer is the 22 meter per second at t equal to 3 seconds. Okay, now next one is students, reverse. Reverse we are going to do. Okay, see here. velocity of an object is given by this one. Calculate the instantaneous position at t equal to 2 seconds, and here initial condition is given x equal to 1 meter at t equal to 0 second. Okay, so how we will approach the question here, please? As, remember that here, dx equal to v dt. Directly you have to remember that. Now integration is this. V is there, we have to calculate the x. Now, so dx equal to v dt integration. Now next steps here, please. This is the dx integration. V value how much is given here? Kindly put the value of this here. 3t square plus 4t minus 1 into dt. First I will simplify this, then I will put the limits. Okay. Now students, what this will become here? See, integration of dx is equal to, again separate it. So it will become 3 will come outside and it will become here t square into dt. Now one step I have reduced. Plus 4 and it will become here t into dt minus what will happen? The dt will be multiplied here, so it will become here dt. Kindly see very well. Now, so 3 will come outside, t square dt, again 4 will come outside, t dt, and again minus dt. Now students will put here the limits. Okay. So what is this? Lower limit we have to put from the given condition. X equal to 1 meter at t equal to 0 second. Okay, so see here, x equal to 1 meter. Which time? T equal to 0, t equal to 0, t equal to 0. Okay. And when we have to calculate instantaneous position at t equal to 2 seconds. So upper limit, you see, this is 2, this is 2, this is 2. Okay. And let's take for example here I have written here the x1. Okay. Great. So now students, now see here very well how we are doing here. Okay. So remember right here, integration of dx will be x. Okay. And where to where? We will write here 1 to x1 is equal to 3. And the formula I am writing here, see, integration of t to the power n dt means always t to the power n plus 1 by n plus 1. Okay, this formula you should remember that, you will get the answers. Now, so what will become here? Integration of t square dt means put here n equal to 2, it will become a t cube by 3. What this will become here, students? T cube by 3. Limits where to where? 0 to 2. Okay, then plus 4. Integration of t dt means, that means t power 1. Okay, so it will become a t square by 2. Okay, what this will become here? T square by 2. Where to where? 0 to 2. Minus integration of the dt means t, and where? 0 to 2. Okay, so what will happen at here? First upper limit minus lower limit. Okay, so first you put x equal to x1 minus lower limit 1 equal to, remember that here, students, see, this 3 and 3 cancel. This 2 2 is 4. Okay, so it will become here, see here, I am writing here t cube 0 to 2 plus this 2 is there, and here t square 0 to 2 minus t, what is this? 0 to 2. Okay, here their mistake may happen, but I will try my best so that the mistake should not happen. Okay, so x1 minus 1 is equal to t cube. Okay, so here first upper limit, that means 2 cube minus 0 cube plus 2 upper limit, that means 2 square minus 0 square. Okay, minus upper limit 2 minus 0. So you know what will happen at here, see, x1 minus 1 is equal to here 8, and here 2 square means 4 into 2 8, and here minus 2. Okay, so when you will simplify this, x1 will come how much here, see, 8 plus 8 16, 16 minus 2 14, and minus 1 will come this side, that means 15 meter. Okay, so in this way we have to do here x1 how much here, 15 meter. Is it? Can you see very well how we have done this? Now this is the reverse process of the differentiation: position to velocity, displacement, velocity to position, integration. Okay, great. Now students, we are going to see here the average acceleration. Now after the instantaneous speed we are going to see acceleration. Now so see here please, it is the rate of change of velocity of an object in a certain interval of time in a specific direction. Okay, so what will happen that here, remember that here this average acceleration is given by here rate of change of velocity. So we will write here v2 minus v1 by t2 minus t1. Okay, what is this? A bar equal to v2 minus v1 by t2 minus t1. Okay, or even you can write here this one as delta v by delta t also. What we can write, students, here we can write here delta v by delta t also. What is this? This is the average acceleration, delta v by delta t. Okay, or even sometimes we used to write here like this one here, a bar equal to final velocity v, initial velocity u, final time t, initial time 0. So a bar equal to v minus u by t minus u. This thing and all we used to see in our 9th, 10th standard. So we can write here, you know very well, v equal to u plus a bar into t, and this you know very well, this is the first equation of motion. This is only applicable whenever uniform acceleration is there. For which kind of acceleration? This equation is valid, uniform acceleration. Okay, so I hope so this is very, very clear to you. Now see, the some important points are there now. So see here, average acceleration is a vector quantity that you know very well. Okay, SI unit is the meter per second square, and see, dimensional formula is how much here? LT minus 2. Remember that here, LT minus 2. And see, average acceleration can be positive, negative, or a 0 because it is the which quantity? It is the vector quantity. Okay, great, great, great. Now students, kindly see here. Now the instantaneous acceleration. Instantaneous acceleration. So let me see here the instantaneous accelerations here. The acceleration of an object at any instant of time is known as its instantaneous acceleration, just like a previous definition. Okay, another way, see, it is also defined as the limit of average acceleration when time interval is very, very small. Okay, so I can write here, see, as a equal to the way we have done before, limit delta t tends to 0, and what we can write here, delta v by delta t. Okay, so students, when you will simplify this, it will come here a equal to what to write here, dv by dt. Okay, or even you can write here, see, d by dt of v when you are going to solve the questions. Okay, so this is the one way. This is the one way to represent the acceleration. There is another way is there. Another way is there. Again. See, this is the important. Again, what is the another way is there? Okay, another way is there. Na? That I will see next. But see here, please. Here, if I write here for the integration point of view, so you can write here dv equal to a dt. Now, dv equal to a dt here. Now, we'll do all together here. Now, so dv equal to a dt. Now, and remember that here, if velocity is there and we want to know the acceleration, differentiation. Reverse means integration. Okay, this also you should know very well. This is the what to tell acceleration we are doing in terms of time. And remember that here, one more thing here, this formula you have to use when velocity is given as a function of time. Now, what I am telling, this formula you have to use when the velocity is given as a function of a time, this thing and this thing. Okay, now remember that here. Now see here, see, you know a equal to dv by dt. Now, a equal to how much here, students? A equal to dv by dt. Okay, so this thing we can write in another way also. See here, please. If I multiplied and divide with the dx. Okay, so see here, into dx and by dx. Even you can write ds by ds also in the general form here. So what will happen that here, students? If I write here, see, this dx and this dt together, it will become here dx by dt. And what is left here? Let me change here the color. So this is dv and this is dx. It will become here dv by dx. Okay, so from here we can write here, remember that here, a equal to dx by dt is what? V and dv by dx. Okay, this is the formula. A equal to v into dv by dx. Okay, and this formula when we have to use? This formula we have to use when velocity is given as a function of position. Okay, velocity is given as a function of a position. Okay, and see, if we see from the integration point of view here, v into dv is equal to a into dx. Okay, and just put here the integration is this. Okay, and here what will be there, students? Again I am telling that here, see, this a should be as a function of position, then only we can use this formula. Okay, can you see very well how we have done this now? Two ways are there. And remember that one more thing here, like here you have written now dv by dt, you can write here one more thing, this is the slope of vt curve. Now, because differentiation now, so slope of vt graph, kindly remember that. Okay, so a equal to dv by dt, one thing, and second thing, a equal to v into dv by dx. You can write dv by ds also in the general form. Okay, now see some important points. First one, see, instantaneous acceleration is a vector quantity, SI unit, meter per second square, dimensional formula LT minus 2, that you know very well, all these basic things and all that. Now see, now students here, please, some very, very basic important points are there here, please. Fourth point, average acceleration can be positive, negative, or 0. Okay, And now the most important point. So see here please. If a body is moving with a uniform velocity, that means velocity is not changing. Which kind of path? Remember, straight line path. Okay. Then its average and instantaneous acceleration is a 0. Uniform velocity means both of them will come 0. Okay. And 6.1c, for a particle moving in a straight line, its acceleration must be parallel or anti-parallel to the velocity. Acceleration parallel or anti-parallel to the velocity. Now see, one by one we'll see. See first case here. Let's take for example here, velocity in this direction, and let's take acceleration in this direction. Both in a which direction? Same direction. So let's take here general sign convention. Velocity positive, acceleration also positive. So you know what will happen here, students? In this situation, when both in same direction, velocity will increase. What I am telling? Velocity will increase when they are in same direction. Similarly, see the second one. If I draw like this here, see, velocity in this direction, acceleration also in this direction. Okay. So here also what will happen here, you can see very well, students. See, basic thing we are seeing, velocity is negative. Okay. Acceleration also negative. Then you know what will happen here, students. In this situation also, what will happen, you know, the velocity will increase. So when velocity and acceleration in same direction, what will happen, that velocity will increase. Either both should be positive or both should be negative. By default, this used to be there. Okay. Now see the third one. Third one, what will be there? See, the velocity this side and acceleration this side. Okay. So here what is this? Both in which direction? Opposite direction. So see here, velocity is positive, acceleration is a negative. I am following the mathematical convention. Okay. So in this situation, what will happen? This velocity will decrease. Okay. I hope so you have understood very well the way we are doing here. See, fourth one, what will happen? Let's take now the velocity is this side and acceleration is this side. Here what will happen? That here both in a which direction? Opposite direction. Okay. So see here, velocity negative, acceleration positive. Okay. So here what will happen here, students? Here also velocity will decrease here. So this kind of things are possible in a straight line motion. Both in same direction, velocity will increase. They are in opposite direction, velocity will decrease. Very, very important. Even in a graphs also, all these basic things are needed. Okay, great. Now let's see here this. The seventh point is this. What is the seventh point? Can you see here? Very, very important. Very important. See, at the highest point of vertically projected particle, vertically projected. Now we are here. Like this is there. Now this is the ground, and we are projecting vertically upward from here. See, we are projected with some velocity. So what will happen here? When it will go up and it will reach at the highest point, you know what will be there here? Here the final velocity will be 0, but acceleration how much here? G. Depending upon the sign convention, it can be plus G, it can be minus G. Okay. So that only is telling here, instantaneous velocity is 0, but acceleration is a non-zero, it can be plus minus G. Remember that here. At the highest point of vertically projected body, what will be there? Velocity 0, but acceleration how much here? Plus minus G. Direction, which side? Acceleration in this direction, the gravity in this direction. Okay, gravity in this direction. Remember that here. Gravity. Okay, remember that here. In case of projectile motion, what happens that here? Ground to ground projectile motion, at the highest point, what happens that the velocity is the minimum. The component used to be, if you remember, u cos theta, and the gravity downward, and at the highest point of the projectile motion, it makes 90 degree. Velocity and acceleration makes how much angle? 90 degree here. Okay, but here we are seeing here the vertically projected motion. Okay, remember that here. Here also see, if I draw here, see here, if in case situation is like this here, no, like let's take like this, like this if we are throwing here. So here at the highest point, just no, let me clear. Here it used to be the u cos theta, and the gravity used to be downward direction, and this angle used to be how much here? 90 degree. Okay, and here we used to throw with velocity u making angle theta. Here how much angle? 90. So this is the projectile motion, this is the vertically projected motion, vertically upward. Okay, great. Eighth one, see, for uniform acceleration of an object, uniform acceleration, see, there should be equal change in velocity in equal interval of time, the way we have done before. I will take here the time, see, t equal to 0, t equal to 3 seconds, no? T equal to 6 seconds, and t equal to how much here? Let's take here, I have taken 9 seconds. Okay, so what will happen here, students? See, for the uniform acceleration, let's take velocity is here 1, velocity is here 4 meter per second. Okay, 4 meter per second, and let's take here velocity 1 to 4 change 3, so it will how much here? 7 meter per second. Here and here how much is this? See, 10 meter per second. Okay, so first 3 seconds change in velocity 3, na? next 3 seconds change in velocity 3, next 3 seconds change in velocity 3. Okay, even you can write 1 to 5, 5 to 9, 9 to 13, now equal change of 4 meter per second. Anything is okay, but there should be equal change of velocity in equal interval of time, then only we can tell uniform acceleration. Okay, great. Now students, see the last point is this, the last point here. For non-uniform acceleration of an object, there should be unequal change in velocity in equal interval of time or equal change in velocity in unequal interval of time. Okay, remember that here. T equal to 0 second, T equal to 3 second, T equal to 6 second, and T equal to how much is this? 9 second. No? The basic thing we are doing here. And here what is this? Let's take velocity is the 1 meter per second. And later let's take velocity has become, for example, 5 meter per second. Then velocity has become, let's take 15 meter per second. And let's take velocity has become 12 meter per second. No? Like this here. So here change, time interval is 3, 3, 3. But here change 1 to 5, 4. 5 to 15, 10. 15 to 12, again 3. But velocity has reduced. Okay. So this is called here what? This is called here, students, non-uniform acceleration. Okay. Remember that here. No? Second thing also, remember that here, equal change in velocity in unequal interval of time also. Okay, great. Now let's see this question. The question is what? See, velocity of an object is given by this one. Calculate the instantaneous acceleration at t equal to 3 seconds. We have taken just similar way. Okay, so see at this. Before also we have done, see, A equal to dv by dt. That means see here, d by dt of v. Okay, and when we'll put the value, before also we have done here, now I'll do here directly. See, 3t square plus 4t minus 1. Okay, so what will happen that here when we'll do the differentiation? Before also we have done 3 differentiation of t square 2t plus 4 differentiation of t, how much here? 1. Differentiation of 1 is 0. So what is coming here? This acceleration will come here, what is 6t plus 4. How much coming here? Acceleration 6t plus 4. At which time? They are asking acceleration at t equal to 3. That means here 6 into 3 plus 4, that means 6 into 3, 18 plus 4, how much here? 22 meter per second square. So only I have put the same function the way I have done for the instantaneous velocity. I only want that you should understand the basics. Okay, now see next one. Acceleration of an object is given by same 3t square plus 4t minus 1 meter per second square. Calculate the instantaneous velocity at t equal to 2 seconds. Given v equal to 1 meter per second at t equal to 0. Okay, I hope so you have understood this also very well. See, as now what we have to do here, see, we have to write here dv equal to a dt. dv equal to a dt. Okay, so again see here, this dv is equal to, put the value of a, what will come here? See, 3t square into dt. Before also we have done that. See, plus 4t into dt and minus dt. Is it? I hope so. You are getting very well. Now, limits please. Lower limit, what is this? See, this one, lower limit, initial condition. V equal to 1, then time how much here? 0, 0 and 0. Okay. And upper limit students, kindly see here please. At which time they are asking? They are asking at t equal to 2 seconds. So 2, 2, 2. And here how much students here? Here it will come here V1. Okay. So kindly see very well. The way we have done before also, no? We'll just go somewhat backside. No? See, somewhat just go backside. No, so see here please. Here also this kind of situations are there. No? The way we have done here, no? Same thing we will do here. The same basics will involve. Here what was there? Here it was coming x1 minus 1. There what will come? V1 minus 1. And this thing will come, V1 will come 15 meter per second. What will come V1? Students, V1 will come here 15 meter per second. Okay, so see here please. When you will do here, it will come here, see, this, see here. V1 minus 1 is equal to what will come here? When you will simplify this, t cube, it will come 0 to 2, plus it will come here t square, directly I am writing here, 0 to 2, and it will come here, what is students here? It will come here 2. Okay. So when you will simplify this, what it will come here? See, V1 minus 1 is equal to, it will come 8, and remember, see, this will come here 2 also, no? Because t square by 2, 4 by 2 means 2. So here that is also 8 minus 2. So 8 plus 8, 16 minus 2, 14, 14 plus 1, 15. So students, remember that here, V1 in the same way, the way we have done before, now see, 15 meter per second. No change and nothing, so only directly I am writing here, okay, because I just wanted you should understand the basics, nothing else I want. So see, last question. Velocity of an object is given by this one. Calculate the instantaneous acceleration at x equal to 3 meter. Okay, so here what we have to do here, here we have to do, see, A equal to V into dV by dx, okay, because here velocity is given as a function of position. So put the value of V here, 3x square plus 4x minus 1 into d by dx, and what is this is here, please, 3x square plus 4x minus 1, okay. Now what will happen that here, see, this is as it is, here no changes, 3x square plus 4x minus 1, this drama is separate, okay. Now what will happen that here, if I see here students, what will happen that here, see, differentiation of 3x square means 3 into 2x, correct, plus 4 into d by dx of x means 1, and here differentiation of constant means 0, okay. So it will come here, see, 3x square plus 4x minus 1, and before also we have done number of times 6x plus 4, okay. So students, this is the acceleration. This is what? This is the acceleration, okay. Now if I put here the value, hence A equal to, at which position x equal to 3, so see here, 3 into 3 square, so 3 into 3 square means 3 into 9 means 27, so see 27, here 4 into 3 means 12, 12 minus 1, correct, 27 plus 12 minus 1, 6x plus 4 into 6x means how much here, 6 into 3 means 6 into 3, 18 plus 4, 22, 22. So what this will come here, see, 27 minus 1, 26, 26 plus 12 means 38, 38 into 22, no? Kindly check out very well, no? Calculations, kindly check out here, correct, na? So 26 plus 12, 38 into 22, now just multiply and all that, it will come how much here, meter per second square. So students, kindly see very well how we have done this, okay students. So I hope so this video of instantaneous velocity, instantaneous acceleration with the important points you have understood very well students. Keep studying, keep growing.